I welcome you all to this mathematics class. I am Miss Vandana Gupta, Assistant Professor of Mathematics. We are doing section 2 statistics, in that unit 4 elementary probability theory. This unit contains two subunits. First one is probability theory and the second one is random variable. We had already started with probability theory in the last week, and whole week we have solved the problems based on probability. We started with the definition of random experiment, sample space, events, what are different types of events, and what is the mathematical definition of probability. Then we use that definition to solve the probabilities of certain given events. We have solved basically 4 types of questions. One was tossing a coin, tossing of 2 coins, tossing of 3 coins. Then throwing a dice, throwing 2 dice together. And different events were given, and we have calculated the probabilities of those events. Okay. Then a card which is drawn from a well shuffled pack of cards. What is the probability of getting? So many events we have taken, like for example, getting a king of diamond, or getting a black card, or getting a picture card. So I hope you remember, and the recordings and the PPTs also I have shared with you. Today I am going to define some different types of events. Okay, so please pay attention. It is very, very important lecture. So before I actually begin, let me revise quickly. What is sample space? The set of all possible outcomes of a random experiment is called as a sample space. You already know that, as the whole last week we have solved problems based on probability, and in each of the problem you have found out the sample space. So sample space is the set of all possible outcomes of a random experiment. For example, if you toss a coin, then what are the possible results? Either it will go in head or in tail. So the sample space of tossing a coin will be S, which contains head and tail. If you are talking about the experiment of tossing a coin. If you throw a dice, throwing a dice, if this is your experiment, then you know that the sample space of this experiment will contain 6 sample points, that is 1, 2, 3, 4, 5, 6, because these are the only possible results of this experiment. We have also found out the sample space of tossing 2 coins together, 3 coins together, or rolling 2 dice together. Okay, so you know what is sample space. What is event? Any subset of sample space is called as an event, or in other words, event is a set of particular outcomes of a random experiment. It will not contain all the possible outcomes. It will contain some typical or some particular type of outcome. For example, if you consider the experiment of throwing a dice, then you know this is the sample space. And if I can define my event A as getting an odd number. So what sample points A will have? Odd numbers out of these are 1, 3, and 5. Odd number means a number which is not divisible by 2. So out of the numbers 1 to 6, odd numbers are 1, 3, and 5. So my event is A. I can define many events like that. I may have another event having an even number. When I roll a dice, getting an even number, that can be called as an event. Or getting a number less than 4, getting a prime number, or getting a number more than 3. In this way, so many events you can have. So the basically event is what? It is any subset of a sample space. Now then we have seen what are types of events. In that, the first one what we have seen was impossible event. Impossible event is an event which can never occur, जो कभी अकर हो ही नहीं सकता है. That is an impossible event. अगर वो कभी अकर ही नहीं हो सकता है तो उसमें कोई भी सैंपल पॉइंट नहीं होंगे, तो इट विल बी अ एम्प्टी event or empty set. So that is denoted by this symbol which is called as phi. Okay, it is also written like this, curly bracket without any member in that. Okay, without any sample point in that. So that is an empty set, but generally we denote it by phi. I have given you some examples of empty or the impossible event. Let us revise them once again. One example what I gave you was, let us see the same once again. In an experiment of rolling a dice, getting number 0 on the uppermost face of the dice is an impossible event. Because when you throw a dice, you will never get 0. Because we know that the dice has only 6 faces, and on none of the face the zero number is there. So this will be an impossible event. Okay. Similarly, you can have many more examples of impossible events. Okay, like in an experiment of throwing a dice, getting a number which is more than 7 or more than 6, they are all impossible events. Or getting a fraction number, 0.1, yes, it's an impossible event. Okay, so impossible event is denoted by phi. If I ask you what is the number of points in an impossible event, it will be 0, because it's an empty event, इसमें कुछ है ही नहीं. तो उसमें n for n of 5 means number of sample points in event, that will be 0. Then we have defined what is certain event. Certain event means an event which is definitely going to occur. आएगा ही आएगा. Okay, that is a certain event. And what is the example? I mean the example of certain event. It is the sample space S itself. So certain event, the sample space S is a certain event. As you know that every set is a subset of itself. So and we define our event as a subset of sample space. And S is a subset of itself. So S is also an event. It is called as a certain event. Okay. Now today we are going to define what is meaning of union of two events. This is similar to the union of two sets, which I have taken when I was doing the bridge course for you. Okay. Union of two events, it is denoted by the symbol which is looks very much similar to U. A union B, U for union. Okay. So if either the event A or the event B occur, or both, then we say that A union B has occurred. Look at what I've written here. If A and B are two events, then occurrence of either of the two events, either event A or event B or both A and B, is called as union of A and B. Or we will say that A union B has occurred. So when will we say A union B has occurred? If either A occurred or B occurs or both occurs, then we say that A union B has occurred. Okay. I have taken here an example to illustrate that. I am taking the same experiment of rolling a dice. You know what is the sample space of that experiment? S contains 1, 2, 3, 4, 5, 6. You already know that. So I've taken a very familiar example. I'm taking here some 3 events. What is my event A? It is the event of getting an odd number when I throw a dice. Okay. So what is my event A? It is getting an odd number. You know what are odd numbers? Numbers which are not divisible by 2. So 1, 3 and 5. These are the odd numbers. So my event A includes the sample points 1, 3 and 5. I have taken another event B as getting an even number. You know what are even numbers? Even numbers are the numbers which are divisible by 2. So out of these numbers, divisible by 2 numbers are 2, 4 and 6. So B will contain the sample points 2, 4 and 6. I have taken another event C as getting a number divisible by 3 or multiple of 3. Any way you can call it. Getting a number divisible by 3. I know what are the numbers divisible by 3 from 1 to 6. They are 3 and 6. So my event C is 3 and 6. So I have taken these 3 events. Now let me give you what will be A union B. When A union B will occur, or what sample points will be there in A union B. So as per my definition, A union B will occur if either A or B or both have occurred. To write the sample points in A union B, what you have to do? First of all, you write down all the sample points of A. What A contains? 1, 3 and 5. So first of all, write down all the sample points of A. Okay. Then write down those sample points of B which have not written here, which I have not written here, because in a set you cannot repeat a number. So in B, 2, 4 and 6, I have not written any of them here. So I will write 2, 4 and 6. So what is my A union B? A union B is, it contains 1, 2, 3, 4, 5, 6. So it is nothing but my sample space S. It is nothing but S. Okay. So here I have written here A union B is same as S. What about A union C? To write A union C, what will I do? Let us first write down all the points of A. What is A? A contains 1, 3 and 5. So I'll write down 1, 3 and 5. C is 3 and 6. 3 I have already written here, so I will not repeat it. 6 is not, has not written here, so I will write here 6. So what is my A union C? It is 1, 3, 5 and 6. 1, 3, 5 and 6. What is the meaning of that? When I roll a dice, and if I get any of these numbers, if I get 1 or 3 or 5 or 6, I will say that A union C has occurred. Okay? Meaning is that 1 has occurred. If 1 comes on the uppermost face of the dice, that means A has occurred. If 3 comes on the uppermost face of the dice, then A and C both have occurred, because 3 is there in A as well as in C. 3 is odd number as well as 3 is divisible by 3. So I will say that A and C both has occurred. If 5 comes, then A only has occurred. If 6 comes, then C has occurred. So A union C is if either A occurs or B or C occurs or both occurs. Okay. So A union C will contain 1, 3, 5 and 6. Similarly, we can write B union C. Again, what is our method to write B union C? What will we do? We will first write down what are the sample points of B. First, we will write down them. So B contains 2, 4 and 6. From C, we will write that sample point which we have not written here. So 3, it is not written. So I will write down 3 here. 6, I have already written because it is there in B also. So 6, I will not repeat. So this is my B union C. Look at here. B union C, 2, 3, 4, 6. 2, 3, 4, 6. I can change the order. It will not matter. Okay. So B union C is this. So if I throw a dice and if I get the number 2, then I will say B union C has occurred because B has occurred. If I get 3, C has occurred, so B union C has occurred. If I get 4, B has occurred. So it also I will say B union C has occurred. If I get 6, then B has also occurred and C has also occurred. So B union C has occurred. So what is actually B union C? It is A union B will occur if either A or B or both has occurred. And once again, to write the sample points in the union, what we do, we first write down the sample points of the first set, and then we write down the sample points from the other set which we have not written here. Okay, so in this way we can find out what is the A union B, what sample points A union B will have. Okay, I can give you another example. Suppose I take an experiment of tossing a coin. And suppose I take the event A as getting a head, and if I take the event B as getting a tail, and if I ask you what is A union B, then A union B, how will I write? First, I will write the members of A, that is H, and then the members of T, which have not come here. So H and T. So union of these two events is nothing but my sample space. Okay. So this way we can write down the sample points in the union. Now go to the intersection. A intersection B. The symbol is this. Reverse U or ulta U. Okay. If A and B are any two events, then occurrence of event A and B both simultaneously is called the intersection of A and B. Here end. If both the events have occurred, then we will say that A intersection B has occurred. Look at the example. I'm taking the same example of rolling a dice. S is sample space, which will contain these points. A will contain 135, B is containing 246, means getting an even number, and C is the same example I'm taking, which I have taken for union here. Okay. Now let us write down A intersection B. As I told you, which sample points will come in the intersection, or when I will say that the A intersection B event has occurred, if event A and B both has occurred. So what I will have to do, I'll have to see what are the points which are there in A as well as in B. Is there any point which belongs to both? No. So A intersection B is empty. Fine. It is an impossible event. Impossible event. Because what is my event A? Event A is getting an odd number. Getting an odd number. And what is my event B? It is getting an even number. And it is just impossible to get a number which is odd as well as even. A number cannot be both odd and even. Okay, so there will be nothing common to these two. So A intersection B is empty set or impossible event. What about A intersection C? Look at here. A contains 1, 3, and 5, and C contains 3 and 6. Is there anything which is there in both? Yes. What? 3. It is there in both. So when I throw a dice and if I get 3, then I will say A has also occurred and C had also occurred, and both have occurred. So A intersection C has occurred. So A intersection C will contain the sample point 3. Okay, which is there in A as well as in C. Similarly, I can find out B intersection C. Look at in B and C what is common? 6 is common. So B intersection C is 6. Because 6 is a number which is in B, which is an even number, and it is also in C. It is also divisible by 3. C is what? C is an event of getting a number divisible by 3. And 6 is a number which is even. That means it goes in B, and also it is divisible by 3. So it is also in C. So B intersection C will contain 6. So I hope you have understood what is the union and intersection of two events. For union, union of two events will occur if either A or B has occurred. And A intersection B will occur if both have occurred. Okay, so you have to see what is common in both the events. Okay, that is how you find out A intersection B. Sometimes it can be empty also. Like for example here, A and B has nothing common. A और B दोनों एक साथ नहीं आ सकते हैं, है ना? तो it can be, it is 5 empty set. Let us take another example to illustrate this. Let us take an example of tossing a coin, tossing two coins. Okay. Example. Two coins together. You know what is the sample space of this experiment? Either both will go in head head. First one in head, second one in tail. Tail head and TT. Okay. Tail tail. Both in tail. This is the sample space. Let me take two events here. Suppose my event A is these are the two events. And if I ask you, what is the union of these two events? What will be the union of these two events? How will you write? First, you write all the sample points of A, HT, TH, and TT. And then from B, you will write that sample point which have not come here. So B is TT, which I have already written. So I will stop here. So A union B is HT, TH, and TT. Okay. What is A intersection B? When will I say that both the events have occurred? Look at what is common to this. A and B. What is common in both? TT. Both the coins are showing tail on the, when I throw them. Okay. When I toss the coin, both the coins are showing tail. So A intersection B is this and A union B is this. Okay. So A union B is actually same as A. Look at this. A, HT, TH, and TT. It is same as A. Okay. So in this way, you can find out the A union B and A intersection B. Now we'll define mutually exclusive events. Two events A and B are called mutually exclusive events if they cannot occur together. Or in other words, if occurrence of one event restricts the occurrence of the other, then such two events are called as mutually exclusive events. What do you understand with that? Two events A and B, we will call them mutually exclusive. अगर वो दोनों एक साथ नहीं आ सकते, if they cannot occur together. Okay, for example, अगर मैंने डाइस को रोल किया and the two events, one is getting an odd number, the other one is getting an even number, दोनों साथ में नहीं आएंगे, या तो मुझे odd number ही आएगा ऊपर या तो मुझे even number ही आएगा, दोनों इवेंट साथ में नहीं आएंगे, तो ये दोनों इवेंट क्या हो गए? म्यूचुअली एक्सक्लूसिव इवेंट. If you want to write it mathematically, these two events will be called mutually exclusive अगर वो साथ में नहीं आ सकते, मतलब उनमें कुछ भी कॉमन नहीं है. A intersection B is empty. Okay, then the two events will be mutually exclusive. Okay, so if you want to check whether the two events are mutually exclusive, what you have to check? You have to check whether they have anything common to them. If they do not have anything common, that means they cannot occur together. So they are mutually exclusive. Okay. Let us see this example. I have taken the same example. S is my sample space of rolling a dice experiment. A is 135, getting an odd number. B is 246, getting an even number. And C is containing 3 and 6. That means the numbers which are divisible by 3. Okay. Out of these three events, which two events you can call as mutually exclusive? Look at this A and B. Both of them, can they occur together? No. There is nothing common in them. A intersection B is empty. दोनों साथ में कभी भी नहीं आ सकते. So these two events are mutually exclusive. Whereas, what about A and C? A and C, yes, they can occur together. अगर मैंने डाइस को थ्रो किया और मेरे डाइस के ऊपर 3 आया, suppose I'm getting 3 here, then A also has occurred. Yes, A में 3 है और C also has occurred. तो दोनों इवेंट अकर हुए हैं. तो A and C are not mutually exclusive because A intersection C दोनों में एक sample point common है. What is that? 3. So when 3 comes on my dice, uppermost face of the dice, then this event has also occurred. A and C also has occurred. So they are, both the events are occurring together. So they are not mutually exclusive. So the best way is to check whether the two events are mutually exclusive is what? See whether what is common in them. If they have something common, then they are not mutually exclusive. If they have nothing common, like this, दोनों साथ में आ ही नहीं सकते, उसमें कुछ भी कॉमन नहीं है, तो वो म्यूचुअली एक्सक्लूसिव हो जाएंगे. ओके, आई होप यू आर अंडरस्टैंडिंग. सो वन मोर एग्जांपल आई कैन गिव यू, लाइक tossing a coin. If I'm in this experiment and if I take two events, one is getting a head and the other one is getting a tail, then A and B are mutually exclusive. Why? Because उनमें कुछ भी कॉमन नहीं है. या तो हेड ही आएगा या तो टेल आएगा, दोनों साथ में नहीं आएंगे, है ना. तो दे आर म्यूचुअली एक्सक्लूसिव. ओके, आई होप यू आर अंडरस्टैंडिंग. Now the second one, exhaustive events. Two events A and B are called exhaustive events if you unite them together, A union B, and you get the entire sample space. Means if you have combined them, combining meaning union, A union B, then you get the entire sample space. That means you get all the possible results of the experiment. Then such two events are called as exhaustive events. Let us see the example. I'm taking the same example. S is the sample space of experiment of rolling a dice. So it will contain the points 1, 2, 3, 4, 5, 6. A is getting an odd number. A will contain 1, 3, 5. B is getting an even number. So B will contain 2, 4, 6. And C is getting a number divisible by 3. So C will contain the same events I have taken. Let us check which events are exhaustive events here. A and B are exhaustive. Why? Let us take the union of A and B. As you know, A union B, how we write? We first write the members of A or the sample points of A, that they are 1, 3, and 5. Then we write the sample points from B, which have not come here. So 2, 4, and 6, none of them have come here. So we will write them all. So what is A union B? It is same as S. Yes, it is same as S. So that means when I combine A and B together, I am getting the entire sample space. A union B is S. So A and B are exhaustive events. What about A and C? Let us see. A क्या है? A is the event of getting an odd number, and C क्या है? Event of getting a number divisible by 3. Let us take the union of A and C. What will I get? A union C. First of all, I will write down the sample points of A, that is 1, 3, and 5. And from C, I will write down that point which I have not written here. So 3 I have already written, so I will not write, I'll write 6. I'm getting A union C as 1, 3, 5, and 6. And it is not my sample space. This set is not equal to sample space. Why? Because 2 is missing here. There is no 2 here. इसमें 2 नहीं है और इसमें 4 भी नहीं है. So it is not S. So that means when I combine A and C, I'm not getting the entire sample space. So A and C are not exhaustive events. Okay. So two definitions we have seen: mutually exclusive and exhaustive. Mutually exclusive means they have nothing common. And exhaustive means if you unite them, you get the entire sample space. Okay. So if by diagram, how can you show that? Suppose this is my sample space S. I take here an event A and I take here an event B. They are mutually exclusive. क्यों? क्योंकि उसमें कुछ भी कॉमन नहीं है, एक्सक्लूसिव इवेंट्स. और अगर मैंने ऐसा लिया, दिस इज माय सैंपल स्पेस, दिस इज माय इवेंट ए एंड दिस इज माय इवेंट बी, this part is common to both. So this is not mutually exclusive. So I hope you have understood the meaning of mutually exclusive. If they have nothing common, they are totally disjoint, exclusive है, कुछ भी common नहीं है, तो they are mutually exclusive. और अगर कुछ common है उनमें, तो they are not mutually exclusive. Okay? And exhaustive मतलब दोनों को मिला दिया, तो you get the entire space. So for example, okay, the same one we could have taken. Suppose I take an experiment of tossing a coin. Okay. You know what is the sample space of this experiment? Take an experiment of tossing a coin. What is the sample space? H and T. Suppose I take here two events. A is getting a head and B is getting a tail. Now let us unite them. A union B. Will it contain H and T? Yes. It is same as S. So so therefore I can say that A and B are exhaustive events. क्योंकि जब मैंने उन दोनों को मिला दिया तो I am getting the entire sample space. Okay. A and B are exhaustive events. Okay. So we have seen mutually exclusive and exhaustive events. Now, as you know, what is complementary event that I have defined in the last week? Once again, we will revise that. If A is any event from the sample space S, then non-occurrence of event A is called the complementary event. Means जो A में नहीं है, outside A. That is the complementary of A. If this is your A, this is sample space, so this outside portion, that is the complementary. Okay. These complementary events are very interesting events because they are mutually exclusive as well as exhaustive. Look at here. A and A complement. They have nothing in common. Yes or no? You can see from the diagram. A is this and A complement is outside A. So do they have anything common? No. या तो A अकर होगा या तो A कॉम्प्लीमेंट अकर होगा, दोनों साथ में अकर नहीं होंगे, तो दे आर म्यूचुअली एक्सक्लूसिव, उनमें कुछ भी कॉमन नहीं. सो A and A intersection A complement is empty, therefore they are mutually exclusive. Also अगर A और A complement को दोनों को आपने यूनाइट कर दिया, A में जो है और A के बाहर जो है दोनों को मिला दिया, तो आपको क्या मिलेगा? The entire sample space. So A union A bar will give you the entire sample space. Hence, A and A complement are exhaustive events. इसलिए what we can say, hence complementary events are mutually exclusive as well as exhaustive. If this is a very important property of complementary events. They are mutually exclusive भी, मतलब उनमें कुछ common भी नहीं होता है, और अगर आपने उनको unite कर दिया तो you get the entire sample space. So they are mutually exclusive as well as exhaustive. A very good example of complementary events, if you go through the same experiment of rolling a dice, and if you take the two events as, you know what is the sample space, if you take the two events as, the first one as getting an odd number, suppose A is this event 1, 3 and 5 and B is getting a even number, then I know that they are complements of each other. A जो A में नहीं है वो B में है, तो A and B are complements. A and B are complements of each other. उनमें कुछ भी कॉमन नहीं है, और जब मैं इन दोनों को यूनाइट करूंगी तो आई गेट S. So A and B, they are mutually exclusive as well as exhaustive, and they are complements of each other. Okay, so complementary events For example number 1. Let us take another example. Suppose I take A as 1 and 2. What will be its complement? जो A में नहीं है. A में क्या नहीं है? 3, 4, 5 and 6. This is A, 1 and 2, and A complement means outside A. 1, 2, 3, 4, 5, 6. This is my S. This is my A, 1 and 2. Outside A, 3, 4, 5, 6. So this is A complement. Okay. What is, if I unite A and A complement, am I going to get S? Yes. 1, 2, 3, 4, 5, 6. And is there anything common to them? Nothing. Nothing is common because जो A में है वो उसके बाहर नहीं होगा. Correct? So empty. So what is A and A complement? They are mutually exclusive and also exhaustive. So this is a very, very important property of complementary events. Complementary events are mutually exclusive as well as exhaustive. I think we will stop here. Tomorrow we will see some problems based on addition and multiplication theorem. So thank you.